My name is Andrei Shofimin. I am a head of digital survey department at SIGNAX. I will moderate the webinar today. We are recording this webinar for those listeners who cannot attend online today. The webinar duration today is approximately 30 minutes. If you will have any question during the webinar, please write them down in the chat and they will be answered at the end of the webinar. Today, we would like to share with you our success story with one of our customers in the UAE. Let's start with a few words about our team. We are an engineering company with construction specialists who have enhanced the efficiency of our projects and are now making these technologies available to the market. We have been in operation for 5 years and have implemented our services in more than 3 million meters of construction sites. While we have offices in Dubai and Boston, we are also expanding our market globally. Today's speaker is Pavel Goretsky. He is a BIM coordinator at SIGNAX with extensive experience in realizing of BIM technologies on construction sites. As I've finished my small part, Pavel, the sun is yours.
Thank you, Andrew. I will add a few more words about myself. My name is Pavel Goretsky. I am a BIM coordinator in SIGNAX MENA region. I am responsible for BIM and digital services on-site implementation. I have more than 5 years of construction experience and BIM implementation in residential housing and industrial facilities. Now I also act as team coordinator and speaker for you today. I would like to start with reintroducing of our products. SIGNAX platform has undergone a significant transformation. Our newest common data environment model DOCS stands as the core model, serving as the central hub for collecting, updating, sharing, and storing all the project information. The inspection model, our 360-degree photo web service, has been enriched with a 2D plans feature and inquiries. Tools plugins for Revit and Navisworks Manage cater to various roles in BIM and site engineering, serving both consultants and contractors. We've enhanced each model by including a complementary dashboard mobile reporting tool. Furthermore, exclusive discounts are available for those opting for the complete power pack. Let's begin with the agenda for today's discussion. I would like to cover all the phases of the project execution, from initiation, staff training, surveying, BIM modeling, to digital twin development. Additionally, we would cover responsible roles from client side and SIGNAX side, alongside with main data flows. During our webinar, we will talk about the software and technologies we used, the challenges we faced, and the use cases that we came across. And I would also like to cover seamless integration in clients' processes and advantages of using SIGNAX models, which I would like to mention. I would like to provide you a brief overview of a project. The SIGNAX team is participating in the construction of continuous basalt fiber production facility located in UAE. The project is being carried out by our client, Bastech, a European-based company that specializes in producing products from basalt fiber and is also the EPC contractor for this facility. This factory will produce basalt fiber and rebar with an estimated annual production capacity of 5,000 tons. The main production building has an area of more than 25,000 square meters and will house 12 industrial furnaces, 18 rebar production lines, 5 industrial dryers, and other innovative equipment. I would also like to mention main benefits of using basalt rebar. It's sustainable as the main components of rebar. Basalt fiber is manufactured directly from basalt rock in a single melt process and comprises only a single raw material. On average, it has 60% less CO2 emissions than steel. It's stronger. Basalt rebar is 5 times lighter and 2 times stronger than its steel counterpart. It's rust-free, so it's naturally resistant to alkali, rust, microorganisms, and acids. Overall, project cost is less compared to steel rebar, including savings on logistics and installation. At the beginning of our collaboration with Bustage, we established project requirements and main goals, which included creating a digital twin for facility management and maintenance. Besides that, we focused on actualization and multi-disciplinary clash detection of existing BIM models, and creation of documentation database linked to elements in the model. Due to further use of our products, staff required extensive training. That's one of the reasons why we decided to deploy one of SIGNAX employees on site. A week after starting our project, we went to the construction site in UAE. We conducted a deep analysis of the initial data. BIM models and drawings were provided by Chief Project Engineer, Construction Manager provided project schedule, and QA/QC Engineer provided shop drawings, material submittals, and as-built drawings. Based on these materials, which was handed to responsible employees, we created a detailed project execution plan and schedule. This helped us to understand our clients' needs. During this stage, we prioritized our goals and began executing the first stage of our contract. One of SIGNAX employees worked on site for more than 6 months alongside the client's employees and consulted them on a daily basis. One of the problems faced by the client was the coordination and updating of outdated models. Some of the discipline models were outdated and up-to-date information was only available in DVG drawings, which made it difficult to simultaneously coordinate various disciplines and check for collisions. To address this issue, we deployed a Revit server that allowed on-site engineers and remote engineers team to collaborate. By using up-to-date DVG drawings to update the Revit design models, we eliminated the need for engineers to manually redraw all the changes in their drawings, thus saving time and reducing the chances of errors. We also taught engineers how to link as-built models, point clouds in their files so they can upload their models regarding as-built situation. For further use of our products, during the construction stage, we provided weekly trainings and supports for the client's employees on working with SIGNAX docs, inspection, dashboards, and tools models. BIM coordinator collected all the required information, current BIM models from chief project engineer, construction manager provided project schedule, project submittals, list of issues was provided by QA/QC engineer. It helped project participants to familiarize themselves with the functionality of SIGNAX models, gain a better understanding of how Revit and Navisworks work, and optimize their workflow processes. Training covered all the SIGNAX functions. Individual sessions with project participants were also held. Chief Project Engineer learns new ways of checking BIM models, performing collision and properties checks, working with point clouds. Construction Manager gains new skills in visualization of project reports, importing Primavera schedule in the reports and visualizing statistical information in graphs. QA/QC engineer learns a new workflow of adding, storing issues in one united space with connection to floor plans. What's even more important, that after the training stage, client continues to use SIGNAX product models. From virtual inspections, which includes aerial surveys, panoramic imagery from inside and outside of the buildings, up to common data environment, which is now used as a central storage and convenience hub for all the project data, shop drawings, as-built drawings, design stage BIM models, regular site reports, material submittals, etc. That was made possible by individual approach to every project participant during trainings, showing them benefits of new strategies or solving their everyday duties and tasks. We also implemented construction progress tracking in this stage by generating and uploading reports for QA/QC engineers and managing team. After regular training were finished, we still provided consultations upon request. The project's main objective is to create a digital twin of the factory main production building. To achieve this goal, it's required to have a precise as-built BIM model on the first place. However, after analyzing the shop drawings and as-built drawings, we realized that it's impossible to develop an accurate BIM model based on them that would meet the specified criteria of the client. It was decided to conduct a comprehensive point cloud survey of the entire object with the Navis VLX scanner selected for this task. Before the start of the process, surveyor provided us base coordinates, construction manager provided master plan and actual floor plans as the initial data for point cloud survey. With this data stored in SIGNAX docs CDE, we were able to start performing a point cloud survey. After conducting a laser scanning, we were able to obtain an accurate point cloud of the main production building, including its equipment and premises, facades, site utilities, and tunnel, alongside with the site structures. We also obtained a point cloud on the master plan and panoramic pictures from points of interest. This service provided us with comprehensive initial data, allowing us to start the next stage of the project. Moreover, alongside laser scanning, drone surveying was performed on-site using photogrammetry technology. This allowed for a more holistic point clouds, identify deviations in the site master plan, and calculate earthwork volumes. SIGNAX survey experts prepared and calculated the road and altitude for drone flights, camera tilt angle, and image capture frequency to ensure optimal photo quality. After the flight, all photos were processed using specialized software employing photogrammetry technology to create a point cloud. The cloud was then coordinated according to the coordinates provided by the customer server, ensuring accuracy and clarity of the data. We also uploaded point cloud in our CDE platform, which allows project stakeholders to have a comprehensive view on a project and even provide measurements using only a browser. Additionally, we performed regular panoramic photo capturing indoors and outdoors, which also helped to visualize week-to-week progress and health safety environments in the construction site. Also, 360-degree images helped a lot in QA/QC on-site engineers' processes. Utilizing this technology, engineers identified a number of issues and deviations in construction process. Moreover, it helped in BIM modeling. It's indispensable tool that adds initial data to the process and allows to have multiple points of view at the site structures which helps to visualize the constructions. Using drone photography, we obtained an orthophoto plan. By comparing the orthophoto plan with the Masterplan, we identified deviations and compiled reports. These reports enabled us to proactively prevent communication layout issues, thereby avoiding collisions with manholes and pipes of the external engineering systems. Additionally, we implemented revised strategies to optimize the project's efficiency and minimize potential risks. We utilize photogrammetry to determine the volumes of gravel and sand that were stored on the construction site. This allowed our clients to accurately calculate the amount of time and workforce required to remove excess gravel and determine the volume of sand needed for on-site applications. As a result, the project was able to save on budget and resources. After obtaining all the necessary initial data, BIM modeling phase started. It was very important to prioritize and categorize the huge amount of initial information. BIM models and initial drawings were handed to SIGNAX team by Chief Project Engineer. QA/QC engineer provided all the material submittals, product catalogs, shop drawings, and as-built drawings. Alongside the documentation, point cloud data were essential at this stage. Panoramic photos in inspection model also find their supportive use cases. By defining the most important areas and systems in every project discipline, we made project execution schedule. The successful collaboration of a remote team of BIM modelers and on-site digital engineer has been demonstrated in practice. The digital engineer has implemented a unified interface to receive all requests from the modelers. This has relieved the engineering team of the client's project and accelerated the provision of necessary information to modelers. Through this approach, the benefits of both remote and on-site teams have been leveraged, resulting in an effective and efficient workflow. The integration of technology and human expertise has facilitated the seamless execution of the project. During the modeling process, most of the discipline's models has to be created from scratch due to the deviations in the position and tracing of systems compared to the design stage model. Lots of new families of equipment were developed based on documentation or point cloud data, if no other data was available. The modeling of MEP systems was performed based on precise point cloud data, with the help of panoramic photos. The whole modeling process was made effective and precise with the aid of multiple sources of information, including on-site digital engineer. Once the BIM modeling stage is completed, we proceed with the creation of digital twin of the factory. This is a process where we integrate all the necessary data and drawings of equipment into the existing elements of the model. Site Construction Manager provides access to equipment sensor data. QA/QC engineer provides all the necessary equipment data to add in properties of an element, such as warranty information, maintenance manuals, and other data that is necessary and required by client. By doing so, we create an object-oriented database that enhances the functionality and use cases of the model. Our plan is to include sensor data in the model, which will make it dynamic and allow us to track the equipment status in real time directly within the model. Once the sensor data has been integrated into the model, it will allow a client to track the status of the equipment in real time. This will enable clients to monitor the equipment's performance and metrics, such as sensor data from the equipment, and identify any issues immediately. In the dynamic world of construction, Digital twins powered by BIM technologies are more than 3D geometry. They are the heartbeat of the project. By integrating metrics into a BIM model, we ensure real-time tracking and informed decision-making. This data-driven approach transforms how we monitor progress and quality of our projects. Furthermore, tracking the data from the model could be even more fluent and descriptive if data is combined in a single report with graphs and metrics, like in dashboard model. This is hugely informative construction dashboard for managers, engineers from any stakeholders that are involved in construction process. Dashboard allows you to see actual and updated information about the project process. Open any BIM models regarding design stage or construction stage and check all the numbers and metrics. Anytime you can select one of the type of the cards inside the dashboard and, for example, perform plans versus actual state of the model comparison. You can see the completion percentage, the scope, and the schedule. Our journey with Bustage in constructing the continuous basalt fiber production facility has been all about innovation, collaboration, and excellence. From analyzing outdated models to creating a digital twin, we, SIGNAX, has showcased the transformative power of BIM technologies to our valuable customer. Through advanced tools, we've overcome challenges and provided solutions beyond all expectations. Our commitment to training ensures project participants gain new skills to optimize their workflow. Moving forward, our focus remains on informed decision-making. In the dynamic world of construction, digital twins powered with SIGNAX solutions are the heartbeat of the project, driving progress through data-driven insights.
Thank you, Pavel. I would like to thank everyone for joining this meeting and being a part of our discussion. Feel free to contact us if you would have any questions or need a demo. Trials are available for testing this system and assessing its compatibility with your project or company's requirements. Goodbye until we meet again.
Thank you.
Thank you. Bye.